Now we're going to look at the sides of a triangle and how that can be used to classify it. So first of all, let's say you know two sides of the triangle. How could I find a third side? Or what are the possible permissible values for the third side? Well, I'll use the triangle inequality theorem to figure that out. First of all, we can assume that A and B are the two known sides, and we'll say they're the shorter sides. So we solve putting in the known sides as the shorter sides and set the maximum value to C. Then we label the longest known side as C and set the other side at B, and we substitute and solve to find the lowest possible value or minimum value. Again, we're not going to quite hit the minimum or the maximum, but we'll approach it very close, and that provides us a range. So essentially, the inequality will look like minimum is less than whatever the side variable is, which is less than the maximum. Now, in this example, two sides of a triangle are 6 and 14 units long. What are the possible values for the third side? So initially, I'm going to assume that 6 and 14 are the two short sides. And so what is the biggest that the long side could be? Well, the biggest it could be is 20, because 6 plus 14 is greater than x. 20 is greater than x, so x can approach 20 but not equal 20. Then I'm going to assume that x is one of the smaller sides. So the 14 must be the longest side. So 6 plus x is greater than 14. Subtract 6 from both sides, so I get x is greater than 8. Therefore, the smallest possible value is going to be just over 8 units long, or basically the side is somewhere between 8 and 20 units. I can also use the sides to classify the triangles, and this basically looks at the number of congruent sides. In this example, I have 3 sides and none of them are congruent. So this is called scaling, when there are 0 congruent sides. I can also have 2 sides be congruent, and this is called isosceles. Now you'll have some people who say 2 or more, but primarily for most of our work, 2 sides is isosceles, and then when all 3 are congruent, we call that equilateral. And if you know any Spanish, equal, igual, and lateral is lados, so equal sides. That's what equilateral means. In this example, I'm going to determine if the sides can be used to make a triangle and then classify it. So first of all, I have to add the 2 small sides and see if it's longer than the largest side. So 5 is the largest side. Is 3 plus 4 greater than 5? Well, it is. So that means I can make a triangle, and it will be scaling. Then I also look at this next set of sides. They're all the same, so it doesn't matter which one I set for C. Is 7 plus 7 greater than 7? It is. So that means that's true. It can make a triangle, and it would be equilateral. Now I have an isosceles triangle where one of the legs is length 12. And I'm going to find the range of possible lengths for the base. Well, the base could be very long. So what is the biggest the base could be? Well, if I have the 2 sides of 12, I know 12 plus 12 has to be more than the base. So the base is less than 24. What if the base is at one of the smaller sides? Then I say 12 is less than x plus 12. Subtract, and I get 0 is less than x. So my possible range of values for the unknown side is anywhere between 0 and 24. So for further reflection, how is solving inequality similar to solving equations? And how do you find a range of possible side lengths given 2 other sides of the triangle? And how is the range different for the base when we're dealing with an isosceles triangle?